Welcome to the annual lecture. My name's George Kernahan. I'm Professor of Health Research at Ulster University and President of the National Conference of University Professors. Today, I'd like to introduce Margaret Cox, who's our speaker. She's an Emerita Professor of IT in Education at King's College London, where she's worked across the Faculty of Dentistry and the School of Education. She's also a member of the Cortex Advisory Board and an honorary professor at the University of Portsmouth in the Dental Academy there. Margaret has been at the forefront of using computers in education since way back in 1969, I think well ahead of the curve. And since 2006, she's also been pioneering how technology like haptics can be used in dentistry and in healthcare. Her research into IT in education is ongoing, and she's been making a difference for decades, really. Margaret's contribution haven't gone unnoticed. She was awarded an OBE in 2001 for her groundbreaking work in computers in education, made a fellow of the Institute of Physics in 2003 for her impact on physics education, and received a fellowship of King's College in 2011 in recognition of her contribution to education. She's also a past president of the NCUP and has been deeply involved in research and policy work, particularly around the role of technology in education. She's also co-edited key publications like Researching IT in Education for the International Handbook of IT in Primary and Secondary Education. In short, Margaret's a true expert and innovator in the field of technology and education, and we're very lucky to hear from her today. So today's lecture reflects on how education and teaching adapted to the online environment during COVID and then afterwards. It's informed by several decades of research and practical experience, offering an analysis of how this period has reshaped the landscape of education. So I think we're in for an interesting session, moving forward to new educational realities. So over to you, Margaret. Thank you very much.
Thank you very much, George, for that introduction. I'm just going to get up my slides, and I look forward to telling you about the changes over the years in how technology has changed. So this is quite a lot I shall be talking about. So I'm trying to tell you a lot in a very short space of time. So one of the things I'll be drawing on is what's happened over many years, because lots of people think that digital era has only recently arrived. Well, it hasn't. So this is going through a historical account of how it's changed and how it's been used in education. So to begin with, there was the IT revolution, which is to extend the human intellectual might, as the Industrial Revolution was to extend our physical might. And now, as you can see on the screen, we have very powerful devices, which are available to almost everybody. But the digital era started in the 1940s. So it's a combination of IT technologies, which include hardware and software. And then I'm going to draw on the research evidence over 60 years, and then try and show you what I think new educational realities are now and going forward. So one of the famous sayings that has been around some time was that it was said that in 5 years' time, we won't recognize schools as they are today. If you ask anybody when that might have been said, they often think it's about 5 years ago. To give you a clue, this is the photograph of the man who said it. And actually, it's quite interesting because he made this announcement in 1973 at a computer-assisted learning conference at Surrey University. His name is Professor Alfred Bork, who's sadly no longer with us. He also said it 10 years later, exactly the same phrase, at the CAL Symposium in the UK, and in 1987 at an OECD meeting, which he and I attended. And I reminded him that he'd said it for more than 10 years now, and that schools were still the same as they ever were. So from then on, he never said it in any of his papers going forward, which is just to show you that an expert at the time really thought that it was going to have a big impact. When it didn't, it took a much longer time. And that's important to remember that. So that was Professor Alfred Bork, who was an advisor to the US government and a physicist based in California. Another thing that happened a long time ago was that a man called Otlet had envisaged that there would be the equivalent of the World Wide Web, but he didn't have the technology exactly as we have now. But nevertheless, in the early 1900s, he created this device which stored over 16 million entries of photographs and documents and films, which he thought that all the world would want to access. So he was over a century ahead of the time, even with the technology he developed. And some people think that we've only been communicating using electronic devices in more recent times. But in 1933, we were using telexes to send messages over the phone lines, and they've been used for many, many years, which we all know about. Now, how did it come about that we were able to use computers and their development? So in 1939, a man called George Stibitz at Bell Laboratories, he developed an adding machine. And you can see it's quite big, although I haven't got anything to go alongside it, which made calculators possible. This was the fundamental basis for calculators. And if you think that robots are new, this robot was built in Westinghouse, and it was built in 1939. It could smoke cigarettes and it could move its head and arms about. And so that was more than 100 years ago, which is a surprise to many of us. Now, the limitations of the time when computers first became available was that mainframes were consisting of what are called vacuum tubes or valves, you can see on the screen. And that particular one there was one of the first in the UK, built in Manchester University in 1948. And it consisted of 18,000 vacuum tubes, and it was very, very large, as you can see, and it weighed over 30 tons. Now, important thing about that is to think about how much energy it also used, because that's a very crucial concern in today's world. So 18,000 vacuum tubes consumed 174 kilowatts. That's roughly 10 watts per tube. Now, we in more recent times, have used silicon chips. And if they required that same amount of wattage, then that means that if your Pentium computer would suck 100 megawatts out of the power grid, and the computer on your desk could easily swallow the entire output of a nuclear plant. So what we're seeing now is, how is it possible that we have telephones, like mobile phones, that are more powerful than all these computers put together? One of the reasons was the miniaturization of binary switches. So if you look on the right, there's our old glass tube. And scientists invented smaller ways of doing it. That just passed a message, a yes or no signal across that tube. So on the left at the bottom, you can see a transistor, which is much smaller and did the same thing. But then scientists realized that they could build a computer chip which was made of metal spewed out in a tiny fine line which crossed other metals, so each of those connections could make up the equivalent of 131 or more thousand bits. In other words, 131 of those devices above. So you can see that it was miniaturizing and making more scope for us. So recent research in artificial intelligence suggests that building computer programs is a powerful means of characterizing and testing our understanding of cognitive tasks. Well, again, you read that and you think, well, I wonder when that was said. Probably in asking the audience, you might say 10 years ago or 5 years ago. And it was however, it was in a book called Artificial Intelligence and Computer Assisted Learning 10 years on, written by Jim Howe at the University of Edinburgh in the Department of Artificial Intelligence in 1978. That was 50 years ago. So artificial intelligence isn't new either. So along with the miniaturization came the ability for mobile technologies. This is just a diagram to show you of how those changed. So to begin with, you had train telephony, which then got developed into airplane telephony. You had handheld radio receivers that came in the 1940s, mobile telephone service in the 1940s. The internet was invented in the 1970s and the World Wide Web in the early 1980s. And then you had hypertext markup languages and browsers. All of these, the point I'm trying to convey here is that they've been around much longer than most people think. So what about actually making them available to computers in the home? Well, in the 1970s, you had a small computer, which was a personalized computer, which was produced to help planning dinner menus and balancing bank accounts, doing school homework. And as you can see, there are three very enthusiastic males looking at the screen and seeing how they can use things online. And at that time, not online, sorry, on their little computer. But there's something missing from that picture, and some of you may spot it straight away. Of course, there are no women, but they did move on in time. So this was the technological developments, a very brief pictorial account of how those changed. So on the left, we have the old computers where you had to store everything on tapes and feed them in, and you had to use card readers. So you programmed your stack of cards and put those into a computer, and you waited for the program to calculate an answer, which might take 24 hours. Then these graphics machines were developed, which enabled you not just to see text on the screen, but graphs. And then eventually you got home computers that could be used as well. And one of the first home computers that was used was called a Commodore PET, which had a screen and its machine underneath. That was followed by the Apple computer, which again was a small computer, personalized computer, and you can see it has a disk drive underneath and also a keyboard. And eventually we got the Research Machines computer for schools in the UK, which was given out as part of the Department of Trade and Industry project. And then some of you will remember the BBC computer, which when it was brought out had no screen with it, unlike the PET computer on the left. So people bought the BBC computer and didn't realize they needed to buy a screen in addition. So the advantage of it was that you could actually use a TV with it to connect and see things on the screen. So what about the interface with human beings? So on the left at the bottom, you can see this is a tablet which you can control by pressing buttons and so on, and actually see different changes in teaching materials on the screen. And here you see the interactive whiteboards that were brought in a long time ago, which were made available to all UK schools. And then, of course, we got to our iPhones, and now everybody's using them on the go and taking them wherever they like. So it's moved from the left hand to a stable stationary system where you had to go to the machine to access them, to a completely mobile system, which you can see on the right there, where everybody can carry them in their pockets and walk about and use them. But let's see what happened in terms of education. So they started to write computer programs to be able to teach children and in schools and universities. So even in the 80s, you had children and parents using them at home. And as you can see, they've now at least accepted that we need other participants like the dog they have there, but still no women around. So in the 1980s, Apple produced this computer to be used after school at home for homework. So in the 1980s, which is 40 years ago, it was anticipated that you'd be using computers at home to do homework. And it also in the 1980s, the touch screen was developed. We all use touch screens, and that means they are haptically enabled. But it was years ago that people first started to use them. So why didn't we all get access to them in those days? This is an example in a junior school where they are connecting and building programming loops connected to a BBC computer on their right, primary school children. So, who pioneered all this IT use in education? It goes back a long way. Jim Howe, I've already spoken about. Another well known person, Mike Sharples, who's been researching artificial intelligence and its use in education since the 70s. Professor Celia Halls and Professor Richard Noss, both at London University, the London Knowledge Lab, have been pioneering the use of technology in education again for more than 40 years. And then we have Richard Millwood on the right, who has developed lots of new ideas. And one of the oldest in the field is Professor Bob Lewis, who developed science teaching software in the 1960s at Chelsea College. And at the bottom, you can see Professor Diana Lorillard, who led the way in the relationship between how teachers can use educational software and what are the opportunities to help them embrace that use when they're teaching university students and school students. Other people in the field that you can see on this slide are those that school leaders who all work for local education authorities, and then academics leading the way in pioneering the use of computer assisted learning in the 70s and 80s. So everyone was trying to improve the way of the quality of the learning achieved of the individual learner. And they thought that they would just give some useful learning material on the computer, which was often called educational software, and give it to teachers and they'd be able to know how to use it in the classroom. So what did happen over 35 years of IT development? So this is just a timeline to show you what was available and what was used and how well it was adopted or not adopted in education. So to begin with, in the 70s, you had students' individual learning, drill and practice. You know, there'd be a math program on the screen and they would all be asked a question and type in an answer. And it was to try and help them learn better concepts and problem solve. Then in the 1970s, they developed to look at the relationships between variables, so simulations and drill and practice. And then further on in the 1980s, people realized that even when you developed all these tools, that teachers still were not able to use them. And so there was a lot of research into the uptake by teachers of technology in schools, which showed lots of promise, but not very widespread institutionalization. So in the 1980s to 90s, then there were lots of research studies into how teachers interacted with students, how students interacted with each other, and whether group learning might be a way of helping teachers get to grips with using technology in education. And there's many, many research documents that look at that in detail. So then, of course, it transpired that people thought, well, why is it that all schools are not taking up all these opportunities? And one of the reasons they considered was that it depended on the policy and practice of the head teachers and the individual schools. And it was often very difficult. So there was a big push to help institutionalize integration with lots of UK government initiatives where they had a scheme where they trained all teachers. In every subject, they had a great big pack, which was enormous, which they all received, and then they had online support. But it wasn't taken up very widely. And the scheme, although it cost over £50 million, came to an end, and still you can go into school in that era and find the majority of teachers not using computer assisted learning in their teaching. So then there was a lot of research into, well, what is stopping this happening? Is it about poor attitude? What motivates them? Is it a balance between online learning? Is it because the curriculum has to change too much and they can't cope with adopting new innovations and new resources in the curriculum when they have all the standard things they have to do to prepare students for exams and so on? And finally, in the early 20s, then there was the challenge of informal and formal learning. The fact that students were learning things unknown to the teachers in the schools because they could access things online and on their phones and smartphones and so on. So, how do we measure the impact that all this technology has on learning? And this is to show it's quite a complex slide, but you can always review it again. Is that you have all kinds of ways of measuring students' learning. If you look on the left, you can do subject tests to see if they learned some physics concept doing one way or another way. You can look at the tasks they perform and measure those. You can video them and look at and see how they're interacting with the software on the screen or with the online learning. And you can then look at the uptake, the teachers' attitudes, the students' attitudes. And then in order to find, well, how does it change the curriculum? You can do a combination of questionnaire surveys or interviews or small group work. So you can see that across all the levels of factors you have to measure, there are different ways that educational researchers measure those. And there are many international comparisons which have their limitations, which I'll mention later if we have time. You know, comparing which country was using computers more regularly in schools and so on. So a very useful model developed by a man called Professor Entwistle, again, Edinburgh University. He looked at a lot of research into the quality of learning achieved and all the variables which would affect that. And if you look on the right, then it was thought that I'll go back one, how teaching and learning the environment would affect the quality of learning achieved, which it does, as I've explained. But if you look again up here, then perceptions of teaching and learning environments from the students would make a difference. Sorry, I keep losing that. And then here, the concepts of learning and so on. And then how the course content is organized. And then the influence of academic communities and validating bodies, whether they are GCSE or A level or university degrees. And then at university level, the university teachers' knowledge about what are they learning when they use these new resources. All these factors will influence the quality of the learning achieved, not just the interaction between the learner and the resource that they're looking at on a screen. So a lot of people try to look at that in more detail. So here we have Nikki Davis on the left, Professor Nikki Davis, who comes from Australia but also worked in America for a long time. And she tried to investigate how teachers, when they were presented with these resources, would really use them. We have Seymour Papert, who's very famous. He developed an online programming software language called Logo. And he believed that given children the opportunity to use this, they'd all learn how to reason and compare diagrams and programming steps and so on. And it was a big movement in the US and in Europe, but it didn't last because the teachers didn't make best use of it. And then over in France, we had also colleagues who were working there who were looking at the use of computers in physics and so on, physics teaching, and he pioneered how that worked in the average French school. Then we have people like Christina Preston, and she could see that if you got learners working in groups, then they could learn much better. And she invented early software which connected children sitting at different desktops together, working as if they were a team of reporters and gathering evidence and sharing it over the screen. And then you have Professor Sir Tim O'Shea, who pioneered the use of Logo when he was at the Open University and has been leading the way in using technology in education ever since, both at school level and higher education. And finally, we have Dr. Mary Webb at King's College London, and she pioneered the use of artificial intelligence by building two modelling systems, an expert system shell in the 1980s and a modelling program. And she evaluated that with lots of children and showed that it really enhanced their ability to reason and build complex models and learn from that experience. So, if we are going to see what is the impact of this technology in education, there are mainly three areas. There's one, the technical innovation, which is galloping ahead, as we can see. I'm going to talk to you a bit later about the haptic element to that. But as I mentioned earlier, we also have teachers' practices, teacher and learning interaction, how it's integrated in the curriculum, and what pedagogical frameworks teachers have to enable them to adopt these new technologies, if you like. And then how do you measure those? Lots of educational evaluation methods, from psychomotor skills to learning computer interaction. So it's a very challenging environment to look at new educational realities. So this is just to show you that years ago, in 2002, 3, 4, and 7, then I mentioned earlier, there were surveys of English secondary schools which were looking at the number of computers in a school. So you can see this was in a secondary school. From 2002 to 2007, it increased from nearly doubled, not quite, to 275. And the laptops went up fivefold. And the percentage of teachers, staff confident in using it didn't increase very much, although it says 81% confident in using IT. But the percentage of all schools with all teaching staff went up significantly. So teachers are getting to grips with using email, but not so much with using it for teaching and learning. So if we look at this relationship between the positive impact in formal settings, then it depended on the functionality of the resources they were using. How robust was it? How reliable was it? What computer platforms were they using? And I highlighted clear screen presentation because I'll show you this is terribly important in whether students and teachers are going to learn using it. And also, as I mentioned earlier, the learning context. Is it relevant to the curriculum? What are the teaching strategies and so on? So all these are challenges which are still here today as they were all those years ago. So this is just to show you an example. In 2025, this is a teaching and learning resource which is developed online, and it's Google Earth. But as you can see, and it's developed to teach children secondary schools. Well, there are about 6 or 7 windows on that screen. It's totally confusing. What do they look at first? Do they look at the one on the left? Do they choose that first? Or do they go down to the bottom? Well, what about the one on the right? How is that relevant to that? Now, that's really complex. And that kind of screen doesn't help people learn at all because it's too complicated. And if you notice on this slide, there are over 1,000 companies in the UK providing learning resources for education, and many of them are like this. And so they haven't really learnt from all the knowledge that we've built up over the 60 years of previous research, is to make it simple, straightforward, and easy to interact with. So other countries have been doing the same as us. So these are just a few examples. In Australia, they studied a balance between remote learning and non-remote learning because, you know, lots of schools in Australia are very remote with small cohorts of children in them. And what they noticed was that the percentage of the over 15 years, how that had spread across. So you can see that Friends, a lot of non-remote learning was used, and remote was hardly anything. And in tertiary education, remote was still a much smaller fraction of those that were working with it actually on campus. Now, of course, that was in 2002. In 2004, a study of Canadian teachers looked to see how good they were at using educational software. This is 20 years ago. And it was a survey. So teachers said what they thought that they could do. So of them, the percentage of teachers who thought they were quite accomplished was 43%. But when you dig down into qualitative research, you find that they only felt accomplished at, say, using email or maybe doing an online search. They couldn't do most of the other things. So it's very uncertain as to what is meant by being accomplished at using educational software. This shows you in more detail. It was a study conducted some time ago, and it was in, again, 2002 in the UK. And what they tried to do was to do a questionnaire survey of the difference between out of school only, in school only, which is the red bars, and both in and out of school. Well, as you can see, I'm not going to go through the whole slide, but for example, we'll just pick a few. If you pick the top one, creative writing, which is, you can do that with wonderful use of word processing in schools, but it was hardly ever used in schools, as you can see. Only 4% were using it, both in and out of school, and in school, only 5%. If you look down to where the greatest use in school was Wikipedia, where the teachers obviously got them to look something up. But all the others, which you can look at up later in more detail, showed that the majority was out of school only in 2002. Now, 2002 was 23 years ago, but it was 25 or 30 years after they had access to these resources. So if we continue, then looking at the balance between informal learning and formal learning. So there was a national survey, and they looked at the use of Web 2, which was a resource provided by the UK for all schools to be able to access educational resources online. And as you can see, the greatest use was search engines, and the smallest use was online encyclopedias. But again, it was really not a great use if you looked at individual teachers using it. So why is it that this occurs? And this is a diagram, which you could call a pedagogical framework, which I and my colleague Mary Webb developed based on an earlier one by Schulman. And what we tried to do was to look at the relationship. If you look in the middle, this is whether learners will participate in the learning activity and therefore improve their knowledge and understanding. Well, it's influenced by the teacher's knowledge and beliefs about whether it's worth using this device to help them. And then their pedagogical reasoning, which means how they think it will fit into what they do and how they teach. And that, of course, will depend on how they then create their course plans and then what they do, whether they put them into practice. It also depends on the students' knowledge and belief, whether they think they're going to learn anything by using this technology, and then how they behave when they actually interact with it. And these lead to what we call affordances, which afford them the opportunities to learn. And so all these factors have been shown by many studies of research and theory that they will possibly stop it being used or limit the opportunities in the classroom, but in some cases, in pioneering uses, then it offers wonderful affordances for students to learn better using this technology. So I'm now going to draw on some of the evidence from an international community called EduSummit, which was set up by Professor Joke Voigt and Professor Gerald Knezek. And it was built on the development of an international handbook, which was 2 volumes, 2008 and 2018. I was the editor of the Researching IT section in both of those volumes. And in the first one, these are the 2 editors. And in the second one, we had 4 editors, all who are internationally renowned for their work in IT in education. And what they did was we got together about 60 authors to write chapters for this handbook. Now, when we did that, we produced the handbook, and then we thought, will anybody read it? Because handbooks sit in libraries and students might get them out. But I've got handbooks here, and I do read them, but not everyone does. So we thought, why not bring together the international researchers, policymakers, government officials, and those advising governments, and leading practitioners to show where we are each 2 years and try and build on what we already know. And it formed what was called the EduSummit community. So this is who we are. It's an international network of researchers in conversation, collaboration with policymakers and practitioners, a network that bears the responsibility to build on what we know And that means building on what has happened before. One of the outputs is an ebook, which is globally distributed to all 220 UNESCO member countries. But we also produce academic papers, blogs, videos, and so on, so that we don't have to keep reinventing the wheel and starting again from scratch. So this is just the example of the EDUS Summit. So we meet every 2 years, about 60 of us in working groups, to try and move everything forward. So this one took place in the University of Laval in Quebec in 2019, just before COVID hit. And you can see there that there are the original founders, Gerald Knesset and Yoko Fucht, and myself and Thérèse Laferrière, who was the co-chair of that event with me, and also Petra, who is one of the key members of the committee pushing forward the Edu Summit goals. This is where we are all represented in the red blogs. There are 38 countries represented across the globe. So one important factor is not to remain just UK-based or Western-based, because there's research going on all over the world in many different languages, but all with the same goals to find out how technology helps in teaching and learning. This just is a distribution of those people. And this shows you just a photograph of all those who attended 2019. And on the left, you can see Thérèse Laferrière, who was my co-chair at this event. So after this event, the teams have to go away and work on new ideas for the next event. And this is an example of where we all get together, which was in my home, and some of us here in the working group putting together. So we have people like from the right, David Gibson, who's from Australia. And then we have on the left, we have a colleague who's also from the Netherlands, and lots of other people who join this committee planning the next working group. So this is how we've evolved the themes since 2009 to 2023. The first one was at The Hague, sponsored by the Dutch and UK governments. We wanted to find out under what conditions does technology have a positive effect on teaching and learning. The next one was in Paris, building a global community of policymakers, researchers. Then in Washington, D.C., supported by the US government and quite a few manufacturers as well, including Microsoft, research-informed strategies to address educational challenges in the digital network world. Then Bangkok in 2015, Borovets in Bulgaria, rethinking learning in the digital age, and Quebec City, as I said, learning and learning context, new alignments for a digital age. And the last face-to-face one was moving forward to new educational realities in the digital era, which is why I chose this theme for this talk. We have one happening in June, which will be in Ireland, where we'll be building on all these previous ones to try and move everything forward. But what do we mean? How is it changing the digital era? So if we look at the research section in the handbook and see how there are changes in alignment. So for a research focus on the left in orange, the technological developments, learner focus, large scale versus specialist studies, and scalability. How's it sustained? Towards intertwined tools, changes in the knowledge representation. You're looking at a screen with pictures and diagrams and text, but students are also learning from videos and from audio and from interacting with feel and so on. So it's all changing towards teachers and teaching learning content, formal and informal learning, assessment through IT, pedagogical reasoning, and the integration within the curriculum. So who are the players in digital education? They are these. You have researchers, and you have policymakers, and you have practitioners. And they all have multiple voices, which are affecting the way we make these new tools available in a digital era. I can't go into the depth of all these diagrams because there isn't time, but you can go back and look them up, and you will find there's a lot of background research supporting all these factors here. So what about in the UK? So what happened some years ago in 2007, our Economic and Social Research Council and Engineering and Physical Research Council set up a technology enhanced learning research program, of which there were 8 projects. And the one that we were involved in was called the HAPTEL project. And this went on till 2012. So I'm going to tell you very briefly about that, because what we wanted to do was to find out how haptics, with the sense of touch and how you feel things with your hands, can help students learn, particularly dental students. So these are some of the team involved in that. And they were pioneers in engineering, like Professor William Harwin, who's a professor of cybernetics at Reading University, and Dr. Jonathan San Diego, who was the manager of the project, and Professor Barry Quinn, who led all the dental students through lots of learning activities around it, and Dr. Ali Barrow, who was the engineer who developed a lot of systems, and Professor Pat Reynolds, who had the ideas of how this might work with undergraduate dental students, and finally Professor Ken Eaton, who has been our advisor and has been working in the field of technology and dental education for more than 40 years. So what we tried to do was to look at how do learners learn if you're an undergraduate dentist. And if you look at the right, they have to learn hand-eye coordination, manipulative skills, spatial reasoning skills, and they also have to learn how to provide satisfactory and sufficient feedback to the students while they're learning. So what at the moment happens in most dental laboratories across the world, our students spend time learning on what are called phantom head machines, which are a bit like when you go to the dentist and you have a drill in your hand and you can work on artificial teeth or discarded real teeth, and you can practice removing caries, drilling into the tooth, cleaning the teeth using water-cooled drills. And you can see the tutors walk around and give them feedback. But often there are, in our case, 77 students in this laboratory at King's College London and only 2 tutors. And so the students have to wait a long time to get feedback on how well they are doing. So what we developed over a period of 18 months was what was called the HAPTEL workstation. And you can see that the student, this is a dental student sitting here, and he's holding a handpiece, a real handpiece in his hand, and he's putting his foot on a real dental pedal to control the speed. But it's not connected to a patient, it's connected to this device, which is a haptic device, which is made for the gaming industry. And on the screen, he can see the drill, and he can see a face and a jaw. And he can also have 3D perception and move his head around and work on a tooth as if it's a real tooth. And so in this case, the tutor's coming around to just help them make sure they're working on the system accurately. And we get 2 students working together. So one is the role of the dental nurse and the other one is the student. So this is just examples of students using the machines. And you can see on the left photograph, there they are working as a team with the woman on the left as the dental nurse and the man on the right operating on the tooth. In the middle, you can see what the student sees on the screen. And he can work through a tooth, and if he drills too hard and breaks it, he presses a button, starts again. You can't do that in the traditional laboratory. This is now what those machines have developed into with other companies. This is a company called Sim2Care, the Portsmouth Dental Academy. It's the same principle, but it's a more refined and more versatile machine. And on this example here, you have on the left a screen which the student can touch it and choose the speed of the drill, the different kind of drill, whether he's choosing a drill or choosing a probe to feel how deep the pockets are in your teeth, and then he can operate on it to improve it. And then if it doesn't work, he can press a button and start all over again. And what the research that we have now spent 20 years doing has shown that when using these machines, instead of working on a patient or in the phantom head lab, as I mentioned earlier, that they get as skilled as those that have spent the traditional time and therefore can move on safely to patients. There have been other developments. So in this one, for example, you might be teaching a student how to give an injection and they don't always get the right location. So you get the student to get a syringe and put their syringe into the mouth, and then they try and give an injection, but they then check to see whether it's right by pushing a button, and then they can see the skeleton and see where all the tissues are to see if they got it right. And there are all these kinds of features. So when all this research was done, it led to developments in other areas, like in art and in applied healthcare subjects. So I'm just going to show you a few of these. So this is another similar device called the Simudont Dental Trainer, which is in about 200 dental schools across the globe to teach the same things that I was talking about earlier, but slightly different design, with new features coming out all the time. You've also got haptic robots where you can put them on your fingers and control the surgery and see how they go when you're actually operating. There is also developed by Professor Sarah Bailey at University of Bristol, a haptic cow, where students can learn how to examine the internal organs like the liver and so on, which they do by putting their hand in the back part of the cow. And it's much safer for them to practice on this than it is with a real cow, which they can then move on to later. But again, Professor Bailey's been researching this for 15 years or more, and it's shown that they can then move on to examining a real cow without having to make mistakes that they used to do without this device available to them. This is another group, only this time in Midwest in America, where they've got the same one but a different cow. They've got Friesian cows over there, and again, they're learning how to use it. The evidence from all this research is that students learn better, safer, and it makes them better prepared for the next stages in their work. Now, alongside this comes, and some of you will know these, they're ocular rift glasses, where instead of the device being actually present in the room with you, it's actually in the screen. So you put those glasses on and you think you're seeing what you saw in the earlier pictures. And so in order to use this, there is a one which enables you to measure a knee. So on the left is a patient who's got a bad knee, and on the right is the operator who's wearing the glasses, and that screen shows you what he is seeing in the glasses. But he holds the syringe in his hand, so it teaches him how to put the syringe in the right place in a knee when there's no knee there at all, really. He feels it. And I've used this device with a company where I've managed to learn how to operate on a spine just by wearing the goggles on my eyes and seeing everything else in the screen. And you have different screens. You can move your eyes. It's called gaze control, which enables you to choose your instrument. So these devices are becoming readily available. There are also haptic ones to help students at school level learn using 3D molecular structures. This is a project between King's College and Reading University. And then, of course, there's 3D printing. So this is just an example of where you can design some fabric and print out patterns using a 3D printer. An ideal use of a 3D printer, which you might like to try at home, is you can buy ones now that will work on chocolate. And you can actually design different chocolate shapes. It costs about £240. And it's easy because it melts at room temperature. The limitations of 3D printers at the moment are the liquid that forms the 3D image has to be liquid form, and it's difficult for all different kinds of solids to be liquid at room temperature. So what about today's visionary teachers? This is just an example of three out of thousands. So it's not all bad news. It's not all that people are not all using them. If you look at these three examples, so Ioana Zaferou from Greece, who was a student at King's College, she's just won a Global Teacher Award because she's been using all kinds of digital resources and AI apps for teaching English as a foreign language, and it enhances the learning experience. And she was a winner of this global prize in the autumn of 2024. Another ex-student, Stephen Trask is using AI platform called Microsoft Copilot translanguaging. So he is using that to help explore the use of AI platform together with Raspberry Pi, which some of you may know about, which is a small device where you can build the circuitry on your own. You can buy the whole package and learn how to develop things yourself. So he's using the large language model to explain programming errors. So it's not all about just getting ChatGPT to write some rubbish in text. It can be used very intelligently to help students learn. And finally, my colleague, Professor Laferriere, is using it with her postgraduate students. So they have to look at roles and objectives in their collaborative work. And the AGI integrates itself as an active player. So it becomes a fellow student in the group, having to make similar decisions and learning to work collaboratively. These are positive uses of AI in today's world, in our new digital era. So how have things changed? I talked about the IT technologies, hardware and software, but what about the new educational realities now, showing you the history very briefly before. So what we've got now is that it's not mentioned everywhere, is we have one of the best computers available to us now, which you all have, and it's your own brain. Because your own brain only uses 20 watts compared with an iPhone, which is also 20 watts per hour. But if we move on to other devices, this is just to make you smile. It's about children not realizing what books are for, although I still think books are very important. So we are looking at the connection between mobile and home. So there's the dilemma. There's a dilemma between formal learning and informal learning. Now we have mobile devices. We don't know where our students are learning and what they are learning. There's how to connect the resources for teachers. And teachers are losing the control of the learner, and they're losing the classroom control. And the positive thing is there's unlimited information to enhance knowledge, but insufficient skills to discern what's relevant and what's useful information. So this is, if you look at the comparison between traditional learning and simulated learning, you've still got to do things in the real world. And so we mustn't move towards assuming that simulated learning is the answer to everything. So this is how one working group who examined the change between human-computer interactions and the move from formal to informal learning concluded. If you look on the left, in the present, we have formal learning in the big blue circle, informal learning, which we have no control over, and then what we call non-formal learning, which is where they are learning with devices which may be instructed by the teacher and they go away and learn it separately themselves. But it's moving to the future when informal learning is much bigger. And there's an interface between formal learning and non-formal learning. And this is where it's a challenge, where we don't know individual learners how much they are always interfacing between those three domains. And that will be the next challenge for the EduSummit team. So this is a perception of what learners are like now, walking along with their iPhones without looking where they're going. But what has changed and how can we learn from that? As if you go back to the beginning, there's size, isn't there? The size of the old computers have got smaller and smaller. The cost has got smaller. The speed has got massively fast. And therefore our time is better used. And we are more or less mobile now. So we have the world in our hands. And two very good books to for further reading, if you are interested, was written by Mike Sharples, who looks at how computers have become real creative writers. And the one I mentioned earlier, The Quest for Artificial Intelligence, which shows you the scope and challenges over 50 years. So what about the limitations? So a lot of people watching this will be familiar with ChatGPT. So you've got AI and artificial intelligence engines. They are worked on the basis of a consensus of knowledge from large data sets, but they don't necessarily record the underlying data. And so they present risks to providing false or inconsistent knowledge. There's also an important distinction between the true logical reasoning and the probabilistic data-driven approaches that underpin AI systems like ChatGPT. While AI can simulate aspects of logical reasoning by identifying patterns and correlations in data, it lacks intrinsic understanding or the ability to engage in abstract conceptual thinking. So there are still challenges. So one interesting exercise you can try for yourselves, which I've done, is to use a number of different AI tools and give it a simple task and then see what the outcomes are for different devices. And you'll see there's a significant difference. In the earlier ChatGPT versions, for example, it would provide you with references, but they weren't real. Although you might think they were real. If you look them up, they weren't. Whereas the one using Skype, which is built around Skype, which is sadly discontinuing, they would provide you with real references. And there are lots of examples like that. But from our observations up to date in our research, is the use of AI is only as good as the person using it. So where are we now? Going back, do you remember the big building at the beginning? This one is called Isambard AI, which is built at Bristol University, and it works at very high speeds, 8.8 gigaflops. That's floppy units per second. But it's estimated to use 5 megawatts of power, and it needs a lot of liquid cooling. Lots of people don't realize that, how much it's cooling. So in a sense, we started in big buildings in the 1950s, and now we're in the 2025. We're back to big buildings, and this time they're using just as much water as before. So what are the implications for the future? The expanding range of representational systems and different modes of human-computer interface, they have profound but uncertain effects on the way students are learning. There's a potential to extend the specification knowledge and knowledge domains that learners now have to deal with. And in a sense, we as educators are losing control of that. And finally, new representation systems like haptic systems, interfaces, speech interface, voice interface require different understanding of the way knowledge is codified and constructed. And that's the challenge for those that have been in teaching for a while, is to keep up with those different understandings. So how has things, to summarize? In the early days, which I mentioned, in order to interact with the computer, you had to have the language of the computer. Do you remember the old punch cards I showed you? You had to know how to type those in and how to put the program requirements into a programming language. Now you don't. Now you can just speak in a voice and say, Google, find this, or AI, I want to know this. And so one benefit is we've moved from the interface between the human and the computer to be more human as far as the computer's concerned. The limits between the traditional and digital computers, as I said, is the size of AI and its energy and water use. So the answer is quantum computing, which I don't have time to talk about today. But if you search on YouTube, you'll find lots of excellent physicists talking about quantum computers, which is the way forward, we hope, which is much more powerful, faster, and smaller. And then what about the barriers to educational use? New IT applications have work time limitations. So do we stay with existing educational strategies? I don't think we can anymore because of how fast things are changing. But teachers need more time if they're going to change. It isn't enough to put them on a short course. It's the same with AI in business. I attend lots of business courses online, and they're all using AI now, but they're all also talking about the need for staff development. And that's where The barriers lie is that staff, i.e. humans, teachers, need more time to get to grips with this. And so the question is the technology galloping faster than the staff have time to keep up? So thank you very much for listening. And I'd just like to acknowledge the contributions of the faculties in which I work: School of Education and Communication Society, the Faculty of Dentistry, Oral and Craniofacial Sciences, and all my colleagues, IGA, across King's. IGA was the e-learning interest group, which I and my colleague Pat Reynolds set up. And then these are some of the key people who enabled me to do all this research: Professor Sanan Wilson and Haptel and Fodok's colleagues, and then the research councils who supported it. And finally, Portsmouth Dental Academy, where I'm currently doing research, who've enabled all these. And finally, I'd like to acknowledge the contributions from various websites to the use of their pictures. Thank you very much for listening.
Well, thank you very much, Margaret. What a wonderful journey, really, through the development of IT and technology to support education. And thank you very much, because you may know that Margaret has given the talk face to face, and we're doing a special recording for you. So having to give the lecture a second time. Thank you very much for that. When we met at King's, there was a lively question and answer session that we're not really able to hold in the same way, although I believe it may be able to follow by editing and putting in that Q&A session just immediately after. So thank you very much for your lecture.
Thank you, George. I enjoyed it, and I hope it will be of value to people, and especially to our NCUP colleagues and those who were unable to attend in person and or online. So thank you very much.
Thank you.